Okay, welcome to the physics video. In this video, we'll be solving a question on oscillations. A student carried out an experiment with a pendulum hung from a fixed support. The fixed support was a distance h above floor level as shown. As the student was unable to measure the length L of the pendulum directly, she measured the distance t of the bob to the floor. She then used the data to plot a graph of t squared against t as shown below. Determine a value for the acceleration due to gravity. So we have seen this type of graphs and we know that the angular speed is equal to square root g over L. And we know that the length L here will actually be equals to, L will be equals to h minus t. So the length L is equals to h minus t. So what I can write here is omega is equals to square root g h minus t. Okay. So now what we know is that give me a second. Okay. We know that omega is equals to 2 pi over t. So now what I can do is I can say 2 pi over t is equals to square root g h minus t. Then squaring both sides, I will get 4 pi squared divided by t squared is equals to g h minus t. Then what I want to do is I want to take the h minus t to the other side, cross multiply. 4 pi squared h minus t is equals to t squared g. Okay? Right. So we have an equation here. And now what we can do is we can compare it with the graph above. So we know that t squared is on the y-axis and we have distance d on the x-axis. Okay. Now what I can do is I can say that 4 pi squared h minus 4 pi squared t is equals to t squared g. Okay. Yeah. Or what we can actually do is we can actually use the expression before. This would make it very more complicated. So we can say t squared is equals to 4 pi squared over g h minus t. And now what I can do is I can say t squared is equals to 4 pi squared g h minus 4 pi squared g t. Okay? So yeah, that makes sense. Okay, now give me a second. Let's move it around. So let's move this there. Let's move this here. Oops. Let's move this here. Let's move this here. Plus. Okay. So now we get y is equals to mx plus c. Okay. All right. So what you can do is you can find the gradient, or we can find the gradient. Instead of finding the gradient, we can actually use the y-intercept as well, right? So that's gonna be actually, or can we? I don't think we can use the y-intercept. We don't have the value of h. We will have to use the gradient then. Okay. All right, let's use the gradient. So let's take two values. Okay, it's not the best visibility. Let's use this value. This one, and then let's use this one. 1, 2, 3, 4, 5, 6, 7. So 11.7 and then 10.9. Alright, that's good enough. So 0.3, 10.9, and then 0.1, 11.7. Alright, I'm going to take that. Let's copy that. Let's bring it down. Let's put this one right over here. Right, that's perfect. So this is x1, y1, x2, y2. So 11.7 minus 10.9, 0.1 minus 0.3. That's going to give me the gradient. And that's going to be equals to 4 pi squared g. So what I can do is g, 4 pi squared divided by 11.7 minus 10.9. 0.1 minus 0.3. So that's going to give me my answer. Let me just calculate that. Right, so the gradient value and all of that, you'll get 9.6 meter per second square. That's right. Alright, pretty simple question. So there's a couple of equations whenever you do these type of questions to keep in mind. One is A is equals to minus omega x minus omega, give me a second, minus omega square times x. Okay, that's the first equation. The next equation is omega is equals to square root g over L. And the next one is omega is equals to square root k over m. The other one is omega is equals to square root k1 plus k2 over m. This is when you have two springs. This is when you have that this system will look something like this. Okay, right. So this mass will oscillate back and forth with both of the springs having different springs constants. This will be when you have a spring, and then when you have a mass, when you have a length L and a bob, and then the last one is going to be omega is equals to square root g over h. This is specifically for a system where you have liquid, basically, right? So the liquid will move up and down and oscillate, okay? And the height h is actually this distance. This entire thing is height h, okay? If anything else is there, yeah, I think that's all. Okay, so next question we'll be trying out a pretty tricky question on oscillations, and it says a simple pendulum consisting of a thread and a bob is set up next to a horizontal rod. The bob is displaced to the left and released, and when the bob reaches the equilibrium position, the thread strikes the horizontal rod. For half of the cycle, only the lower part of the pendulum moves. Okay, so we're going to have this entire thing, it's going to be moving to this direction, and then this upper area will kind of get stopped, and only this lower area or the lower length of the thread will move forward. Okay, so now we have the diagram, and they've given us some values. So they've given us the length of the total length of the thread and the length of the upper area of the thread. And what I can do here, just looking at this, I can also find the length of the lower area of the thread. So that's going to be 67 centimeter minus 24 centimeter. That's going to give me 43 centimeters. So basically we start from this point, let's call it A, and we move to this point called B. Now our thread is at a point B. Now after this point, the upper area is stopped and the lower area, which is this area, will move forward. So the lower area of the thread, or the lower length of the thread, moves forward to a point C. And both of this point A and the point C are the amplitude or the maximum displacement positions. Okay, so let's divide this into two parts, part 1 and part 2. And in both of these parts we have different lengths. Here our length is going to be 67 centimeter, and in the second part our length will be 43 centimeters. So here it will be 43 centimeter. Okay, so I hope what I've broken down here is pretty clear. I've tried to make it as simple as possible. So in the first part, our entire length will move up until the point B, and then from B to C only that lower area will move. Okay, now what does this mean for us? So we know time is equals to 2 pi square root L over G. That means that T is directly proportional to square root L. That means if length changes, if L changes, the time period will change. So notice here we have a different length at this oscillation and different length in the second part. So in the first oscillation, or the first part, we have 67, in the second part we have 43. So time period here will be T1 and time period here will be T2. My main point here is that we have two different lengths, right? So we need to have two different time periods here as well. And when we do something with these values, we add them up, we're going to get an answer. Okay, I'll tell you how we will go about this. Okay, so first let's do this. Let's find the time period for both of them. Okay, let's find the time period for our first part and the second part. So let's find for the first part. Let's call it T1. So I've plugged in the values and now let's get the answer. That's going to be 1.64 seconds. Now let's find for the second part where only the lower length moves. And we're going to call this time period as T2. So that's going to give me 1.315 seconds. Now, the next thing you have to know is that for half the cycle, only the lower part of the pendulum moves. How do we understand this? So I want to show you a quick drawing that I'll draw. Now notice, okay, notice what's going to happen. So we will start from here. Okay, so from point A, we're going to go to point B like this. Okay, then only the lower part will move like this. Okay, so we go from here to here, point A to B. Then our length changes, so we're going to go with a different length now from B to C. Then from C to B again we come back, and then from B to A. So notice this is half, right? There are four things, right? Four things. So we have four different movements, and half of the movements are with our length of 67 centimeter. And the other two movements are with a length of 43 centimeter, which means half of the time, half of the cycle, and the other half of the cycle, right? Half of the cycle, we're moving with a time period of 1.64, and the other half cycle, we're moving with a time period of 1.315. Does this make sense? Okay. Which means, now what we need to do, okay, so for half of the cycle, we're moving with 1.64, and for the other half, we're moving with 1.315. Now, the time period T1 and T2 are for 4 movements. What does this mean, sir? Let's take the time period of 1.64. What does this tell us? This tells us that if the length was 67 centimeter, then the oscillation would go like this, would come back, or 1 second, it would go like this, then we'll go like this, then we'll come back, and then we'll go like this. So 4 movements, right? Look, notice 4 movements. And this time period tells us that if the length was 43 centimeter, right, then we'll go like this, like this. So it's always 4 movements, right? So for 4 movements, for a complete cycle. Now notice here, we only have 2 movements. 2 movements. So for 2 movements, I'm just going to divide these values by 2. Notice here we have 4 movements, right? But I'm looking the time taken for these 2 movements. So I'm going to do time period divide by 2. That's going to give me 1.64 divided by 2. 0.82. 1.315 divided by 2. 0.6575. Okay. Now I'm going to add the values. So I'm going to get 0.82 plus 0.6575 seconds. This is going to give me the time period of the oscillation of this, where we have 2 different lengths and it's kind of weird. So that's going to give me the time period for this. So let's add both the values out. So that's going to give me 1.4775. And now we can find the frequency doing 1 divided by the time period. So that's going to give me 0.68 Hertz. Okay, so I hope this is clear. Again, if you don't get the idea of this, I understand it's a bit difficult. You can also take the hint from the question. So half of the cycle, only the lower part moves. The other half cycle, this entire thing moves. So half cycle is this, and the other half cycle is this. It is a bit tricky. I recommend watching this again and trying the question yourself. Then you will really get the essence of this question. Alright, that's about it.